told you there were some limitations in 2G, 3G. That's why IP core network came, packet core, LTE architecture, and there were few limitations in packet core, a 4G network as well. That's why 5G core network has come. Now 5G is comprised of 5G NR, 5G new radio, as well as 5G core architecture. Today we will discuss about 5G core. 5G NR is completely different based on the radio technology. It depends on the how deployment has been done for a particular operator in any country. It may be standalone, that will be a true 5G. It will be on the G node piece with XN interface in between G node piece. And if not described by the operator or allowed by the operator, then it will be standalone plus non-standalone. There will be a fallback to LTE technology as well along with 5G. So in that G node B will communicate to E node Bs as well for the communication. That all comes under the 5G NR radio part. But today we will discuss on the 5G core part. So as you can see in my screen, this was the LTE architecture for 4G deployment. And here from the UE till E node B and till SGW, this was the RAN part, radio access network. And from MME, SGW to HSS, OCS, this is our ECE, PCR, PGW, this was our packet core part. So here the base limitations was it has too many protocols. Like when MME needs to communicate to HSS, it was over S6A interface that was on the diameter protocol. When MME has to inquire anything from E node B radio part, it will go to S1 AP protocol. S1 MME is the signaling path, but the protocol used was S1 AP here in 4G deployment. I'm talking. When MME needs to any signaling made connection to SGW, S111 interface was there, but the protocol was GTP control plane. GTP stands for GPRS tunneling protocol. When MME needs to inquire for any fallback scenario, MSC or VLR, it will go into SGS AP interface. So there were too many protocols. MME as an entity alone had to troubleshoot and all that handle. Okay, are you getting point, Shiva and Utkarsh? Mohan, huh? Hello.
Yes, sir. Yeah.
Yes. The main point was that the EPC limitation was that there were too many protocols MME had to handle. Okay, thus the second limitation was the gateway selection inflexibility was there. Here you can see one E node B can connect to one SGW on S1 user plane interface. And one SGW can connect to multiple PGWs, depend upon the where in which PLM and PGW resides. But here limitation was that gateway selection was that one E node B can select only one SGW at a point. Here multiple E node B cannot, one E node B cannot connect to multiple SGW. This was the limitation, right? Hello.
Yes. Like what? This E node B will transfer all the data signal to data incoming data request to SGW, right?
This yellow part is control plane in which signaling carries, and the green part is user plane in which traffic flows for packet core. Okay. So one E node B can connect to one SGW only. This was the limitation I'm saying.
Okay.
One E node B cannot connect to multiple SGWs for user plane.
Okay.
But one SGW can connect to multiple PGWs on S5 interface for the normal scenario and S8 for the roaming scenario. S8 interface. Okay. So basically, 4G packet core was on the hardware-based architecture. Like everything was on the bare metal. It has all like dedicated core, functional entities, proprietary protocol, but it was not scalable. Scalable, what we can understand, the scaling cannot be done. 5G core is all like everything is on the service-based application, service-based architecture. It has virtualization, it has network slicing, cloudification is there, application programming interface, APIs, REST APIs are there, open APIs are there. Communicate for 5G on the REST APIs instead of the diameter protocol. This is the 5G architecture I have taken from the Google. So it will run on the HTTPS 2.0 protocol, and this will run the JSON-based protocol. JSON is the Java Server Object Network, because it has the exposure to the third parties. It has backward and forward compatibilities. Everything will be on the cloud native environment for 5G network. So for like when we were talking about this architecture, we also tried to install the CUPS interface. CUPS was this control and user plane separation, but it did not work efficiently. This was the evolved packet core, EPC, right? Now this is the the link which were described in the 4G, and now for 5G we are checking this. So 5G is basically a cloud native type of environment. All nodes will be on the cloud native. It will have a container, microservices, everything will be there. Till then, any question for anyone, please? Invitation.
Okay. And other than this, we don't have some Cloudify and all those things, right? What you are explaining.
Pardon?
On cloud architecture, maybe not supported by 4G.
Yes.
Yes, 4G didn't support cloud applications.
Like virtualization, in which we can deploy a hypervisor layer on a bare metal, and we can install a VNF. Basically, as a VNF, we can install a MME. As a VNF, we can install a SGW, PGW. But that was all on the this hypervisor layer. When we removed the hypervisor layer on the cloud architecture, we install there a Docker or a container-based engine. But any Docker can be done, or container D can be done, or Rocket can be done. These are all the container-based run engine. So Docker is very famous in the network. That's why everyone is discussing about the Docker. Anything, maybe after 2-3 years, Rocket is also a competitor of Docker. It may also come. Container D is also a competitor of Docker. So it may also come. So for 5G, for cloud native, this we have seen that it has the cloud native applications. Cloud native applications have the microservices, and in the, as I told that in microservices can run in virtual machines, but in cloud native environment, they run inside the containers. Any microservice will run inside the containers only. And for the orchestration or the management of containers, we have to deal with the pods, which Kubernetes handles. So Kubernetes is responsible for handling the pods, and Docker is responsible for handling the containers. Okay. Now, second point is REST APIs. What are REST APIs? These are the representative state transmission RESTful APIs. It will run on the HTTP 2.0 protocol on the JSON format. So whenever any external or internal communication has to be done, it will be done on REST APIs only. No diameter will be running for the 5G environment, as everything is on cloud native, rather than the virtualized network as we were seeing in 4G network. Okay, so these are the multiple points: microservices, DevOps, continuous integration and continuous deployment methodologies. So we can have another session for the DevOps part or another part. Okay. So 5G system includes 5G new radio, as I told in the beginning of the session, and 5G core. 5G core can be described on the reference-based architecture and service-based architecture. Now, service-based architecture is the thing we have to follow for everything. Okay, so this is the typical 5G core diagram. Here, this is our UE, our mobile set. This is our radio. This will be comprised of the G node B. Instead of E node B, we will call it a G node B. Okay, and this is our UPF. UPF is our user plane function. So as I told you that we try to segment in the cups, control plane and user plane separation. So in 5G, only UPF will come under user plane function. Other entities will come under control plane only. Okay, it will come, UPF will come under user plane. This is user plane function. Packet data session, packet routing, forwarding, packet inspection, enforcement of user plane, quality of QoS handling, quality of service handling. Okay. If we compare this entity UPF to 4G. Okay, Mohan, Utkarsh.
Yes, sir, Pith.
UPF will act as a SGW, PGW for user plane only. Okay.
One more thing, this earlier you said Docker is.
That was the this I was saying the cloud native applications. So like cloud native is everything is on Docker and container based applications. So your microservices runs inside the containers in cloud native environment. There are containers as well. Like for example, each virtual machine needs a separate operating system and hence they are resource like intensive. Container in any contrast to virtual machine can share the same host operating system like a Linux kernel they're sharing. This makes containers a very lightweight, portable and fast to start up. In the this hypervisor layer architecture, there was no container. So every virtual machine, every VM machine has their own footprints of operating system. That's why they were very heavy and they were not easily portable to deploy any other. We were discussing this UPF, na?
Yeah.
Okay.
See, now UPF is equal to our SG signaling gateway, means SGW and PGW, right? That is the UPF user plane function, and which covers the E node B also, means nothing but that is a G node B, correct?
G node B, but G node B we will not consider for UPF because G node B is a part of RAN, radio.
RAN, okay, radio, okay. From packet switch, it is a SGW, PGW replaced with the UPF. Right?
Yes, UPF, yes.